In this example, we're going to have a look at some sampling methods that are involved in statistics. So there's three methods that we're going to use in this course. So it's simple random sampling, which is essentially picking a number, systematic sampling, and then finally stratified sampling. So the first one is simple random sampling. So we've got some screenshots here that you might be able to read, but you can generate a random number on your calculator. So if we go to options, the arrow across, number with F4, integers with F2, we get this symbol. And then we can press exit, and we want to press probability. And we want to choose a random number, so random hash. And what this does is it generates a random number. But at the moment, we haven't told it what we want it to generate. So what we can do is put in some parameters. So I'm going to say, I want you to pick a number between 100 and make it a random number. So then I'll press it again, and you can see each time it generates a random number. So if I scroll back to the top, integers, and then you choose a number and put in a random number. But if you're asked in an exam to come up with a random number, my advice would be the examiner isn't going to know if you just chose a random number or if you put it into your calculator to work it out. So really it's a little bit of an obsolete method in terms of our exam, but it's still good to know. So the next one we're going to look at is systematic sampling. So we're going to look at the example from the textbook. Management of a large city store wishes to find out how potential customers like the look of a new product and whether they would buy it. They decide on 5% systematic sampling procedure. So what does this actually mean? Well, what we can do is we can break that 5% into a fraction. So 5% is 5 over 100, which is 1 out of 20. So what it means is if 20 people walk past, we're going to ask the first person that walks in, and then we would ask the 21st person that walks in, the 41st person, or conversely, like the option here, the third person, then you would choose the 23rd person. So it's very systematic in its approach that you're counting out the number of people that you're going to look at, so 20%, or the 20th person, sorry, 20 people in total, and you'll choose one person out of that. For example, if I had 10% systematic sample, that means 1 in 10 people. So I might choose the first person, the 11th person, 21st person, so on, until you have enough data. That's systematic sampling. Stratified sampling is to try and get an accurate representation across all different, in this example, year levels. So in our school there are 137 year 8s, 152 year 9s, 174 year 10s, 168 year 11s and 121 year 12s. So a stratified sample of 50 students is needed. So for example, if we were doing a survey about uniform and I chose 50 students and most of them were year 12s, you would all say that you dislike the uniform. But conversely, if I asked a whole lot of year 8s, they will probably say, yeah, it's fine, it's quite comfortable compared to my primary school one. But that's not an accurate representation of what's happening at school. So if we tally up the total number, 137 students in year 8, 9, 10, 11, 12, we've got 752 in total. Now what we've done, there is a fraction of 752. If there are 137 year 8s, that gives us a fraction of the total amount. But we know that we want 50 people surveyed. So here's the total. Here's how many there are in that year level. We want a fraction, the equivalent of it. So we put that into our calculator and we find that's equal to 9. We do the same with the year 9s, year 10s, 11s and 12s. So we can see that these numbers add up to 50 because each one is a fraction of the total. So that's how we might do a stratified sample. So just add them all up and then multiply by however many you need. There are some other methods that you might see used as well. What we're looking at in those examples is when we need to do a sample of a particular thing. But what happens if you have to do a sample for something you don't know how many people there are that do it? So if we're going to look at an example here of weight reduction. So we need to take a sample. Well, how many people need to lose weight? Well, we don't know. So there are other methods that we can use. So often the population size isn't known. And we can use these formulas they can use these formulas to find out how many people we should do to be accurate. So mathematically it is accurate. Please don't ask me how they came up with these numbers because I don't know. So in a large population where you don't know, if you want to be accurate within a percentage, what we have to do is the number of people sampled is equal to 9,000 divided by the percentage squared. So if I wanted to be accurate within 5%, it would be 9,600 divided by 5 squared. So I'll pop that into my calculator, and that's how many people I need to survey. When you do know the population, so let's say that there are 100 students doing maths in year 12, we need to take a sample of that. It's 9,600 multiplied by n, so in this instance, 100. And again, if we want to be accurate within 5%, divided by 9,600 plus 100 multiplied by 5 squared. And we pop that into our calculator, and that tells us how many people we need to sample. So we'll do one quick example. To examine the proportion of successes of a new weight reduction drug, a sample of users needs to be taken. How large a sample must be taken to be very confident that the sample is accurately reflects the population of users within 3% if the population size is unknown. So we don't know the population size, so we're going to have to use n is equal to 9,600 divided by r squared, which in this instance is 3. 9,600 divided by 3 squared, which is also 9. So 9,600 divided by 9. Again, I'm going to pop that into our calculator over here, get out of that. So we've got 9,600 divided by 9 is equal to 1,066. So that's how many people you would need to survey to find out if your weight reduction drug was effective. If you had to do a quick way of working out how many people to sample, a perfectly acceptable method and a commonly used one is taking the square root of the number of the population. So if you know it, a quick way might be to take the square root. So if we combine the two maths apps classes, there might be 36 students, and we need to survey if they've enjoyed the course. So we would take the square root of this, and we would say that that is 6 students. To be more accurate, what we like to do is add 10% of this on. So plus 10% of n. N was 36, so we're going to add 10% of that. So we might survey between 9 to 10 students, and that's even more accurate. So if you had to remember one quick way of working out a sample size, use the square root of n plus 10%.